Eighth graders, we're going to be starting chapter 2. This chapter is going to be all about using integers to deal with equations, and we're going to be starting with some pretty easy equations first. So this is very much a review, except we're going to go right to integers rather than just the positive integers like we've done in the past. Lesson 2.1a is solving addition and subtraction equations. The first equations I'm going to talk to you about are addition. We talk about undoing the addition with the subtraction. What we're really dealing with is using what is known as the inverse operation. In example A, we first have to recognize that this is an addition equation. So we are going to start with the inverse operation. We first write down the equation as it's given to us, k plus 7. Then we're going to subtract 7 equals negative 3 minus 7. Remember, if you subtract 7 from one side of the equation, you must subtract that 7 from the other side as well. 7 minus 7 is 0. So on this left side, we simplify or reduce it down to a k. On the right side of that equal sign, this is where you've got to remember your integer rules from chapter 1. This is subtraction, so we add the opposite. Negative 3 plus negative 7 is negative 10. Sometimes they will write an equation in this type of format, and it's a little tougher for us because we prefer to have the variable on the left side. We can do that, and in fact, we prefer to see the variable written first. Using the commutative property from chapter 1, we know that we can rewrite 9 plus v to v plus 9, and then equals negative 2. Now we can go about the solution. V plus 9 minus 9 equals negative 2 minus 9. In fact, if you want to go right to this step of v plus 9 minus 9 equals negative 2 minus 9, if you want to go right to that, you may. You do not have to write v plus 9 equals negative 2. Going back to what we've just written, we can now simplify. V equals, add that opposite. Remember, with subtraction, it means to add the opposite. V equals negative 11. Now at this point, it's probably a good idea to think about the fact that we can check our answers. Not just look on the solution set, but actually check our answers. We can take this negative 10 in example A and put it back into the equation. You can do this mentally. Negative 10 plus 7 equals negative 3. And yes, that's what our equation is supposed to equal. So we can ask ourselves, if I take negative 11 plus 9, am I going to get that negative 2? Yes, I do. So therefore, I have a higher likelihood of having my equation solved correctly. What about if we start with subtraction? Well, if the original equation is subtraction, then yes, the inverse operation is going to be addition. So I'm going to have x minus 7 plus 7 equals negative 10 plus 7. X is going to equal negative 3. Check it out. If I take negative 3 minus 7, do I get negative 10? Well, if I add the opposite, yes, negative 10 equals negative 10. In example B, here again, we prefer to have that variable on our left side, then go ahead and write it there. N minus 2 plus 2 equals negative 2 plus 2. We can do it all in one step. Okay? On the left side of the equation, it's reducing or simplifying to n, and negative 2 plus 2 is 0. We'll check it out. If we take 0 minus 2, are we going to get negative 2? Adding the opposite, 0 plus negative 2 is negative 2, and yes, negative 2 equals negative 2. There will be story problems. The wind chill outside was negative 10 degrees Fahrenheit. This was 35 degrees Fahrenheit less than the actual temperature. What was the actual temperature? Think back to the first lesson we had on writing expressions, chapter 1a. Less than means to subtract. We're taking less than the actual temperature. We do not know the actual temperature. So that's going to be our unknown. That's where we're going to use our variable. So I'm going to use an n for the actual temperature. Less than means to subtract. 35 less than that number, minus 35. Remember back to 1a, less than was one of those that you have to be careful for, because instead of saying 35 minus n, it's usually going to be changed around to n minus 35. Notice that you have this word was up here. That's a clue word for an equal sign. Is, am, was, were, has been, will be. Any form of that verb to be is actually replaced with equals. And in this case, it's negative 10. Now I have to show my solution. And minus 35 plus 35 equals negative 10 plus 35. On the left side of the equation, it is going to simplify down to n, because to take away a 35, but to put that 35 back is like you've basically haven't changed anything at all. So that means n. And now negative 10 plus 35 is going to be 25. But this is a story problem, so that means we need a label. And that concludes our first lesson in Chapter 2, 1A. Scouting out.